super cool. Here, I'm gonna start writing some of these down. Author, comic book illustrator. Oh, I spelled illustrator wrong. Surgeon, deep sea biologist from Coven. Vishit says an entrepreneur. Yeah, that's a great one. Hold on, let me see if I can spell this. Newer. Okay, that's a hard spell. Cypherny says a professional sleeper. I'm not gonna write that one down, but if I could sleep all the time, I would do that for sure. Manit says a CEO. Very cool. Wait, I'm not sure who this person is with all the. Oh, that's Oshrit. Okay, wait, I couldn't tell. This is investment banker. Awesome. Abdul says computer engineer. Cool. What else? Epidemiologist. Wait, that's so cool that you know like such a I would say like a more niche career. Epidemiologist. Ologist. Okay, that's hard to spell. I don't even know if I spelled that right. But that's really cool. Very cool. And he says an ice cream tester. I'm pretty sure those exist. So that could definitely work. And Vika says that would be the best job ever unless they make up some weird flavors. That's true. I don't know if you guys like I don't know if you guys still do like the jelly bean thing. I don't forgot what it's called, but there's like a jelly bean challenge and they give some like pretty wacky flavors and you kind of have to guess. I don't know if that's still a thing, but it was like super it was like the rage when I was younger. But yeah, that's what I'm reminded of. Manit says video game creator, which I think is a more cooler answer. Video game creator. That's really awesome. I like how there's like some creative stuff in here. That's really cool. Let's see. And because his best job would be video game tester. Yeah, the video game testers do exist, so like that could totally be a job. Kevin says the NOAA. Oh, awesome. Working with the NOAA. That's amazing. Let's see. Sai says a scientist. I like that. I like that. Scientists are cool. Manit says doctor. Very cool. Manit just wants like all the careers. He's like multi-talented, which is great. Kevin says Harry Potter jelly bean contest. I don't know. Oh, it was the Bean Boozled. That's what it's called. Yeah. There might have been a Harry Potter themed Coven, but I can't remember ever doing it. But yeah, Amaria, the Bean Boozled thing. That's what I remember. Yeah. Okay, yeah. So you guys still do it. Okay, cool. That's like core childhood memory. So like, if you don't know what this is, like, I would definitely like check it out because it's very interesting. Let's see. That says a scratcher. Awesome. Not like a back scratcher, like a programmer, which is cool. Manit says GBI. I have no idea what this GBI thing is, but I will put it down. Azarov says tennis player or computer engineer. Ooh, playing pro is cool. Definitely a lot of dedication. Tennis player or computer engineer. Working in CDA. Okay, now we're just throwing some crazy abbreviations that I don't know. You guys got that. You guys totally got that. Oh, Georgia Bureau of Investigation. Oh, that's very cool. Wait, I think that's super cool. Wow. Vicious says swimmer. Awesome. I know FDA is Food and Drugs Administration. I don't know what CDA is, though. Okay. Cool. Anyways, wait, this is really cool. I love seeing all these careers. And I think it's worth noting that this will probably end up changing. You definitely have a lot of room to experiment. So don't constrain yourself. But yeah, this is really cool, you guys. I just love how you guys have a vision. That's awesome. Okay, great. So for today, I kind of wanted to do like a bunch of problem solving so that way we can kind of test out the ideas that we've learned the past few weeks. So today will be very, very problem heavy and really no lectures from me because every problem we're going to do is going to be a problem that uses some of the strategies we talked about previously. Yeah, Manit, this is our last class for geometry. Oh, yeah, CDC. Okay, that's really cool, Malvin. That's awesome. Okay, cool. So lots of government agencies. Great. All right, let's go ahead and take a look at our first question. It's a big question, so here's what I'm going to do. It's got, oh, that's not what I'm going to do. Whoopsies. Here we go. All right, so here's the problem, which is honestly a little gigantic, but I promise not all of this is like relevant entirely. I feel the diagram is going to be a little more helpful. Okay, so this is an AMC problem, or an AMC 10 problem. So I don't know how many of you guys have taken the AMC 10, but fear not, I promise you, it is not going to be impossible. You guys can definitely do this. In this case, you can trust the diagram because it is drawn to scale, yes. And also, like, the diagram is referred, like, it's used here. Yeah, yeah. Oh, is the question, are you guys able to see the question? Is half blocked. Oh no. Here, let me stop sharing and then reshare. Is that a little clear? Or like, is it still broken? Oh, wrong screen. Oopsies. Wait, what did I end up sharing? Oh, you guys saw absolutely nothing. Okay, Google Chrome. Okay, yes, this is what I want to share. Okay, you guys saw no answer. All right, are you guys able to see the question now? Yes, okay, awesome, awesome. Yes, yeah. Could I move the question to the left? Yes, that's the left, I think, yes. Okay, stellar. Okay, great, great, great. Awesome. Yeah, and then Wednesday will be our last class for algebra, in case anyone was curious. Okay, yeah, once again, I know this question is like super intimidating. You can use this diagram. If you want to draw it on paper as well, like you're welcome to do that. This is one of the few times where like this diagram is like actually to scale. And the reason why you know it's to scale is because the lengths actually match up with what's given here. Also, this is like drawn on a coordinate plane, so it's a little harder to like, I would say, like, mess up the diagram because the lengths and all the angles are given to you appropriately. So in this case, like, yes, you can use the diagram, which is one of the few times I'll say this. But yeah. Okay, does this involve pi? Yes, because we're dealing with circles. I would say yes. Okay, cool, cool. I'll give you guys like another 10 seconds. And then, yeah, I think Ashraf would like to explain. So yeah, once you're ready. Okay. All right, Ashraf, go ahead. And why do you think the answer you got? How did you get to the answer?
So how I got to the answer is I first tried to find the area of that white semicircle that we see.
Mm-hmm.
And the area I got for that is using pi r squared. I got 9 by 4. But then the semicircle would be divided by 2. So that would 9 pi by 8.
Mm-hmm.
And then I found the area of like the whole quarter circle, like including the white thing. And then I got uh, 9 pi r and 9 pi. And I subtracted it from the beginning thing.
This beginning thing. Okay,
Wait.
awesome, awesome. One thing I'll say is
Oh, wait, no. I did 9 pi by 4 and then subtracted.
Okay, perfect, perfect. I think you caught it. Yeah, yeah, yeah. Otherwise, fully agree with your approach. So thank you, Ashraf, for unmuting and sharing. I think that was awesome. Even though you guys had accidentally seen the answer, I'm glad you were able to understand like why this was correct. So let's go ahead and like recap what Ashraf did, which honestly is the best way to answer this. So honestly, like half this stuff is not necessary because it's all like in the diagram, which for us, thankfully, is to scale. But you do have to read this at least once to verify that this is to scale. Once you know that, it's very easy to see like visually what we're looking for. Basically, we want to find this like shaded region, right? This shaded region by itself is a little hard to find. Like it's not any like normal shape that I know. I don't know any like formula or anything. So what can I do? I try to look for shapes where I do know how to find the area. And there's a couple of things that I can see here. First, I can see that there's a big quarter circle. Super easy to find the area of that. And there's also a semicircle, and it's pretty easy to find the area of that too. So if I can take my big quarter circle and I can subtract the area of this white semicircle, I'm going to be left with this shaded region, which is exactly what I want to fall. or exactly what I want to do. So let's go ahead and check that out, right? So we're going to find the area of this big quarter circle, and we know its radius is 3, so we'll say that the area of this circle is 9 pi, and because it's a quarter circle, that means it's 1/4 of the entire circle. So we're going to do 9 pi times 1 over 4, okay? That's the area of the entire quarter circle, which I'm going to outline in green. Okay, and then we have the semicircle. So in this semicircle, once again, we can figure out that the radius is actually just going to be 3/2. That's kind of given to us both in the problem and on this diagram. And so that means the area of the entire circle is going to be 9 pi over 4. But because this is a semicircle, we're going to take 1/2 of that. Okay, so if we go ahead and actually I'll draw the semicircle, I'll outline the semicircle in red so that's clear too. Oopsies. Okay, great. So that's our semicircle. And so if we go ahead and kind of multiply this all out, we'll get 9 pi over 4, and we'll get 9 pi over 8. Okay, and so to find the area of this shaded part, we said we could take the green part and subtract the red part. So doing that with the values we have here, 9 pi over 4 minus 9 pi over 8 will give us the answer of 9 pi over 8. Yay! Okay, yeah, it was unintentional to use Christmas colors. I didn't mean to do that, actually. Okay, and while you guys are chatting, asking questions, let me see if there's anything that anyone was confused on. Osher says, 1, never trust the diagram, like never trust it no matter what. Yes, I would agree with that. The reason why I say it's okay to use a diagram is because you've already like read through the question and you know that it's true. But if you still don't want to trust it, like it doesn't take that long to draw your own diagram, so don't worry. Awesome. And because it's much easier than it looks, thankfully, I agree. This is a hefty paragraph to get through, but it's the problem itself, like the concepts itself, you guys all know. Awesome. Okay. Coven asks, do we do 4 times 2 for the denominator? Yeah, so the 4 times 2 is coming from 9 pi over 4 multiplied by 1/2. So like 9 pi times 1, that's where you get the numerator. 4 times 2, that's where you get the denominator. But yeah. Okay. Okay, let's do a quick recap just so that we're all on the same page. So basically what we're doing in this question is we want to find this like shaded area, right? So to find the shaded area, because there's like no formula or no easy way to do that, we kind of have to look for areas of shapes that we do know. So we take the big quarter circle, which kind of makes up the outer part of the fin, of this shaded shape, and then we take the inner semicircle, which makes up the inner part. So these two shapes form the boundary of the fin that we're looking for. So if we take the outer quarter circle bit, and then we subtract this inner semicircle bit, we'll get the thing in between, which is the shaded region. So what this math is doing here is it's finding the area of the quarter circle in green, and then the area of the semicircle in red, and then subtracting those two values here. Okay, so that's kind of a quick recap of this problem. Awesome. So if there's any other questions, let me know. Otherwise, we'll go ahead and kind of move on. Okay, I don't see any questions, so I'm going to go ahead and clear our screen. Okay. There we go. All right, next question. Again, we have another diagram. But you guys use your judgment to see if this diagram can be trusted. Molin says, if I do a question first, I would not like to elaborate because I'm really shy. That's okay. If you do a question first and I call on you, there's a good chance like you are onto the right part, Malvin. And even if you say something wrong, I don't really care. I'm just really happy that you decided to unmute. So if you want to like share, please don't be like scared, because we definitely want you to share your ideas if you have a really good way of solving something. Cullen says, I don't know about this diagram. Let's see. If you want to draw your own diagram, like that's okay. If you don't know whether or not you can trust the diagram, I would say like edge on the side of caution and choose to draw your own diagram. Okay, Malin says 2 pi as a brief estimate. Awesome. Minnie agrees with 2 pi, and so does Nahal. Cool, cool, cool. Minnie says exactly 2 pi. Vishit says 2 pi as well. Okay, awesome. Kevin says 2 pi. Okay, cool. So I think we're getting a lot of answers. So let me see if I can call on someone. Malin, are you sure you don't want to explain your solution? Yes. Okay, that's a-okay. If you want to put it in the chat, that's fine too. We'd still love to hear from you. Okay, who else put in an answer? Okay, I saw Manit next. Manit, would you like to go ahead and share?
They're saying there's 7 small circles, and it says that each small circle has a radius of 1. And then since, as you can see, there's 3 circles like piled right on top of each other, you can realize that if there's 3 circles, 1 for radius of each of them, that means that the radius of the big circle is 3. So 3 squared pi is 9 pi, and each small circle is 1 squared pi, 1 pi, and then multiplying that by 7 pi, so 9 pi minus 7 equals 2 pi.
Amazing. Thank you so much, Ranit, for unmuting and sharing. Okay, and because you went super duper fast, let me just go ahead and write this down. Okay, awesome. So once again, we're dealing with another shaded region, which again is like really hard to figure out. There's like, I would say there's no formula for this, right? Like we have to like use the shapes that we do know how to find the area of and kind of like manipulate them a little bit. I think this diagram looks a lot like you take a piece of dough and you're like cutting circles into it. Maybe if you guys like use Play-Doh or you bake or something and you're like using a cutter to like cut something, I'd say this is what the diagram looks like. And basically what you're trying to do is you're trying to find the area of like the scrap piece that you pick up, right? So that's kind of a little hard to do sometimes. But anyways, what we're doing here is we're taking the area of something that we do know. We know the area of this entire like big circle because we can easily find a radius. And we're subtracting something that we also can figure out the area of, which are all these 7 small circles. And so when we subtract all those little areas, we're kind of just left with this shaded part, right? Which is like the scrap material that you pick up after you use your cookie cutter or whatever. So in this case, we find the area of the big circle, which like Minnie pointed out very cleverly, it has a radius of 3. That's because we have 3 circles along the diameter. And so we can say the entire diameter is 6, radius is 3. Okay, so to find the area, we'll do 3 squared times pi. That's the area of the circle. So the area of the big circle is going to be 9 pi. The area of the small circle is going to be each of these like radius, which is 1. We do 1 squared times pi, so each of these have area pi. And because there's 7 of them, we'll multiply by 7 to get 7 pi. So if we subtract the area of the big circle from each of the areas of the small circles, we're left with the area of this shaded stuff in between, which is 2 pi. Okay? Really great work, Minnie, on sharing that, and thank you to everyone who also put in solutions in the chat. Amazing work. Okay, Atharv asked, why do you square 3? We know 3 is the... Okay, 3 is this radius, and so to find... Oh, whoops, I guess you can't really see that part. Oopsies. Okay, 3 is like the radius. Yeah, I didn't like think that through. I like put the color in the wrong place. Okay, 3 is this entire radius, right? So you'll square it to get the area of the circle. So square it and multiply by pi. Yeah, I realized like maybe it wasn't clear that I didn't write that. Okay, awesome. Let me check the chat, see if there's any questions. Mom says, I stutter when I talk. That's no worries. As long as I can understand what you're saying, I don't really care at all. And I think everyone's really happy when, like, I'm not the only one talking. I think it's a little more exciting for everyone. But yeah, no judgment at all. But thank you anyways for sharing, Malden. We appreciate your solutions and your ideas. Okay. Ostrich says, I did the same thing. It's like the question where there is a shaded circle in the square and it asks to find the area of the unshaded parts. That's exactly correct. The approach to these kinds of problems where you're asked to find like the unshaded or the shaded region is typically to like take the area of something you do know and subtract the area of something else that you do know to find the area of something that you don't know. So I think that's like a good way to approach these kind of problems because oftentimes you're asking to find the area of like some wonky shape. Like I really don't know what to do to find this area if I didn't have these circles as reference. So yeah. Okay, cool. Any other questions? Each circle is congruent. Yes, that is given to us in the problem. Now Hall says, can we do a similar question? Yes, the next question will be like similar, but I think a little leveled up. Cool. Minnie says, is it just me or did you just hear a buzz? Oh, I don't know. I don't know if I heard a buzz. Let's see. Coven says, Spirit has anything? Okay, yes, Coven, that is correct. Cool. Oh, again? Okay, that's super weird. Let me see if I can fix that. Let me give you guys this next question, and then we will fix that thingy. Okay. Alright, so for our next question, we are again working with shaded areas. Okay, this is a pretty big diagram. Okay. Let's see. Sorry guys, give me a moment to get the diagram all fixed. Okay, there we go. So here is our next question. And while you guys are solving this, I'm going to try to figure out what this buzzing noise is. Okay, awesome. Let's see. Okay, Mom says pi over 2. And Vika asks, how do we calculate the extra area? Oh, do you mean like this overlap area? Yeah, that's something you definitely have to account for. I would say maybe think of like, oh, whoops, that was like a really horrible curve. Okay, I would say take a look at like what this shape looks like. There is definitely going to be a lot of additions and subtractions here, so be really careful about like what areas you're able to find and like what each part is adding, whether each part is added or subtracted. Yeah, this one definitely has a lot more moving parts, so definitely take your time with it if needed. Nahal says 2 pi. Oshrit says pi over 2. Nahal says pi over 2. Okay, Nahal changed the answer to pi over 2. Minnie agrees. Rishav agrees. Awesome. Okay, great. So Coven says it's the first circle minus the other circles. Oh, and then Jason agrees as well. Okay, great. First circle minus the other circles, good. Malin says, I think it's because the semis, and it might be a fraction, so it might be pi over 2. Okay, awesome. So we got some general ideas here. Let me see, who is the first person to do this? That I'm not called in. Okay, Rishav, would you like to share how you got pi over 2? No? Okay, no worries. Who else? Oh, Jason, would you like to share? No? Okay, that's all good. Malin, are you up to sharing or are you okay? Do you want to pass? You're totally welcome to share. Like, we'd love to hear. I'll pass? Okay, cool. So we'll do this one together then. No worries. Alright, so like I said, this question does have a lot of moving parts. So here's what I'm going to do. I'm going to draw some extra lines, which is honestly like the key in a lot of geometry problems, drawing like extra lines. Okay, so here's what we're going to do. We are going to draw the intersection points here and here. And then what I'm going to do is I'm going to connect these intersection points with some stuff. So I'm going to connect to this center and this center. And then I'm also going to connect each of these to these endpoints over here. Okay, so let me explain my motivation for this. Anvika pointed out a pretty interesting point that there's like some overlap going on and it's hard to measure that essentially. So what we need to do is figure out how can we account for this overlap. The best way I would say is to break this up into pieces that are like easily manageable, right? So we can pretty easily like find the area of these equilateral triangles. We can also find the area of these bits over here. And so with that, we won't have to do as much adding and subtracting, okay? So in this case, like once again, we need to find the area of this big semicircle with radius, I believe that's radius 2. And then we need to subtract each of these smaller circles to find this gray shaded area, okay? So basically, like what we're doing by drawing these 4 lines to intersect with like the semicircles and their centers, we're splitting this white region into like 5/6 of a circle with radius 1, and then we have like 2 equilateral triangles with side length 1. Okay, so let me explain where this 5/6 stuff is coming from. I want you to ignore this dotted line. Better yet, I will cover up this dotted line for you guys. So the dotted line is going away now on both sides. So that's kind of there to help you guys see like where the semicircles are coming from. But if you erase it, you'll actually notice that this is going to be 2/3 of a circle, and this is 2/3 of a circle. Or sorry, not 2/3. That should be 1/3. My bad, you guys. I don't know why I said 2/3. Okay, sorry. This is 1/3, this is 1/3, and then this is 1/6. Okay, and then we have these equilateral triangles, which we know how to find the area of anyways. So each of these each of these like make up a circle with radius 1. So what we can do is find the area of radius 1, and that's just like pi, right? That's like 1 squared times pi, which is pi, and we'll multiply that by 5/6, because 1/3 plus 1/6 plus 1/3 is going to be 5/6. Okay, so the area of the circular parts are 5/6 pi. Then we have the area of these triangular parts. So the area of a equilateral triangle is the square root of 3/4 times the side length square, which in this case is just 1. You can either see that by like noting it's the radius of this semicircle or like this segment over here. Okay, so this is going to be square root 3/4, except we have 2 of them. Okay, so each of these are going to be square root 3/4. Square root 3/4. Okay, so we found that the area of this white section, this honestly looks like a caterpillar almost, it's going to be the sum of these 2 things. Okay, so we need to subtract that from this big semicircle. Sorry. This big semicircle has radius 2, so we'll say that its area is 4 pi, and we're going to take 1/2 of that, which is 2 pi. Okay, so this entire semicircle is going to be area 2 pi minus 5/6 pi plus the square root of 3/4. Okay, so if you go ahead and like do all that jazz, you get, let's see, what do you get? You can really only simplify the pi's because there's no square roots. So you get 2 pi minus 5/6 pi, which is 7 pi over 6 minus the square root of 3/2. And I realized I forgot to multiply this by 2, so let me squeeze that in there. Okay, oopsie daisies. This is why you should always write your work neatly. Okay, great. So that becomes 2. Okay, and this is our final answer. Alright, let me pause because there was a lot of things going on here, and I don't think anyone actually got this final answer, which is a lot more complex than anticipated. So take a second, like digest this, and then if you have questions on like what the process is here, please ask. So I'll wait a couple seconds for that, and let me see if there's any questions in the meantime. Kevin says it looks like pie. Yeah, it kind of does. Also, I'm like hungry, so anything that looks like food. Minnie said it is 2 over 1/3 pi because the overlap is 2 over 3 pi. Okay, interesting. I like that that line of reasoning that you had, Minit. Kevin says it looks confusing now. Kevin, let me know if you were still confused on that diagram. I think the weird part was when I erased the lines that they had given us. But honestly, like, it doesn't matter whether you have them or not. I just did that so like it was easier to see. It was easier to see like what I was talking about with like the third circles, the 1/3 circles, and like the equilateral triangles. Oshert says you probably calculated the sum of both beforehand. Wait, I'm not sure what that is in reference to. Oh, yeah, no, I'm never gonna find the decimal values of these if that's what you're referring to, because that's like crazy work. But yeah. Okay, cool. Okay, you guys can't see the whole thing? No problem. Let me. Oopsies, that's not what I wanted to do. Okay. Rashov says, it looks a little bit more confusing. Oshert says, can I try to recap to see if it makes sense to me? Okay. Okay, awesome. So let's do a quick recap because I think this problem is definitely deserving of a recap. Okay, so starting off, what we're doing here and what we're trying to do here is like, again, use our similar tactic of finding the area of this unknown region by finding the area of something that we do know and subtracting the area of something else. So in this case, to find this region, we're going to take the area of a semicircle, which is super easy to find, and we're going to subtract this somewhat semicircular looking shape, okay? The tricky part arises because these circular shapes are all kind of overlapping. So what I did here was try to break this up into pieces that I can handle. Now, we know that there are 3 semicircles present, so there's a couple of ways you could go about this. The first way is you do what we did here, and you kind of like draw the intersection points and connect the intersection points to the centers, and you'll see you get like 1/3 pieces, 1/3 pieces, 1/6 pieces, and some equilateral triangles, which is totally a good way to go about this. If this is not intuitive, which honestly like it is sometimes not intuitive, I would say like another way we could go about this is, let me bring back the lines that I erased. Another way that we could go about this is instead we're going to draw all 3 semicircles, and I'm going to kind of do this in purple and erase the lines that I have drawn in blue. So this is all going to go away. Goodbye. Okay, instead what we can do is like draw this and like make a semicircle like this and make a semicircle like this, okay? Now this probably seems more intuitive because like you already are given semicircles, so it's much easier to like just complete the semicircle and kind of finish it from there. I will say like this is a completely fine approach. It just involves more calculations and you have to be very careful with like what you're adding and subtracting, okay? So you can take each of these semicircles, but when you do that, you have to subtract this area, like because it's counted twice, right? If you just sum up all 3 semicircles, you're counting this intersection area twice. So you need to subtract that again, okay? So I would say like there's 2 different ways to kind of go about that, but once you figure out like how to get this area, you just subtract it from the main semicircle and then you get your shaded area like we've done before, okay? Was that like general explanation like clear to you guys? Is that okay? Asha says, I want to try a similar problem because you explain it now. I want to see if I understand. Okay. I was actually thinking we would maybe move on to like a non-circular problem. Let's see if we have time at the end of class to come back to one of these because there's definitely some other kinds of problems that I would like to do. But there will probably be a good variety in the homework, so you guys can definitely like still practice this. Cool. Okay, yeah, I know a lot of you guys want to do some extra, so we'll see if we can squeeze some time in at the end. I do want to cover some of the other kinds of problems, though, for sure. Okay. Awesome. Wow, you guys are. I hope this was like challenging. I hope this was at least somewhat challenging. Cause wow, this if this is not challenging, oh man, I don't know if I have anything extra challenging. Okay, so our next question is not going to be circular. Hope maybe that's a relief to some of you guys. I would say it is still challenging. Oh, I'm glitching. Oh dear. Please let me know if I glitch again. Astrid says, after you explain, it's not hard at all. That's good. That's my job, to make things clear to you guys. Okay. Oh my gosh, I have so many. Yes, diagram is coming. Alrighty. Oh, the buzz is back. Dang it. Okay, let me see if I can figure out what that is. I thought I fixed it before. Okay, here is our diagram. So go ahead, solve this problem while I figure out what this mysterious buzz is. Okay, awesome. Hopefully that issue is fixed, but while I was figuring that out, you guys have been super awesome on solving this question, so I see a lot of people saying 2. Okay, let's go ahead and take a look. Awesome. So we want to figure out, okay, I feel like maybe this diagram needs to be a little bit bigger because these kinds of things tend to have lots of stuff. And Coven, if you're still solving, no worries. Everyone works at their own pace. I personally take a lot more time on geometry problems because sometimes there's things that like I don't necessarily see originally, so like no worries at all. Cool. So what if you would like to share? Yeah. Since Minnie asked, Minnie, would you like to go ahead and share?
So as you can see in the diagram, the 4 part, D is in the middle of E and C. And then that means if you split it in half, it would be 2 as the base for BDCB and 6 as the height. So 2 times 6 divided by 2 equals 6. So 6 is the area of BDC. And for ADE, it's 2 times 8 equals 16. Divided by 2 equals 8. And that's the area of ADE. So 8 minus 6 equals 2.
Okay, awesome. I think you are on the right track, but okay, yeah, I think you're on the right track, but there's a little bit of confusion with what the areas are looking like. So first of all, Minnie, thank you for unmuting and like giving us a solution. I think that was awesome. Let's see if we can backtrack and see kind of like where this might have gotten a little off track. So I agree, like I agree, like D is a pretty significant point in this problem, but I'm not sure I agree with like dropping this altitude. I see the intention, you want to make like a right angle, altitudes are always awesome, but I would actually argue like we can probably figure out this area like we can probably use the right triangles that we already have to like figure out some areas on their own. Also, I like what Jason says about the ratio. It's important to note that like this will probably not be exactly 2 because the triangles that it's like splitting up have different side legs. They're not equal, so there's gonna have to be a little bit of consideration of that ratio here. I would still argue like these are similar triangles, but I would say like maybe like that's not necessarily something we can work with right now. So what I would first start off by doing is finding the area of the right triangles that we have right now. So we can see that the area of like EBA, which is like pretty clear right triangle, is going to be 16, right? And what I'm going to do is I'm going to erase some of these other lines for the time being. Okay, so EBA is going to be 16. And remember, we denote area like with brackets. So EBA. And this is going to be, the area of that is 8 times 4 over 2, which is 16, okay? We have a height of 8 and a base of 4 divided by 2 comes out to be 16. I'm going to do the same thing with triangle ABC. That's going to be 6 times 4 divided by 2, which is 12, okay? So we want to find the difference between ADE and CDB, okay? So that would basically actually end up being like, we can, okay, so hold on. Like kind of the weird place where this is going, like, is this part, right? Like this DAB is kind of messing things up for us. Because if you take a look at like CDB, you can actually find the area of CDB by taking the entire area of CAB and then subtracting this DAB bit. Okay, I think that's kind of like a crucial point here. You could also like alternatively do this problem by like figuring out what this altitude and what this altitude is, but honestly, like I think this is a lot more clever. So let me pause here. Like, does it make sense why we're like splitting up this triangle? How we're able to split up CAB into 2 different triangles? Is that like clear to everyone? Okay, yes, awesome, good to see. So we can actually say like ADE, and here's where I'm going to switch colors, so this is like super clear. ADE is going to be, that's this triangle, right? So it's going to be like this big triangle, which we found the area of. Let's see, we said that was EBA minus X. Okay, so that's like this bit is this blue part. And then the green part, which I'm going to show here, CDB, is going to be ABC minus X. Okay, so that's going to be this thingy over here. So if we actually go ahead and subtract these, and I'll do this in orange, we get EBA minus X minus ABC plus X. Okay, and so you'll notice that these x's cancel out, and we're just left with EBA minus ABC. And we know that's very easy to find. 16 minus 12 is 4. Okay, and that is our final answer. All right, there was a lot of like hand waving going on here, and maybe it wasn't clear like the exact strategy we took. So take a second to like process the writing on the screen, see what's happening, and if there's like a step that confuses you, let me know. Because I think sometimes like the geometry steps are easy to like get overlooked just because you see some shapes that look similar. So let me know if like anything was confusing here, and we can definitely talk. Because I know a lot of you had initially put 2, so I want to make sure why it's clear that is not the answer. Okay, so you guys are saying ABD is equilateral. Is that told in the question? It is not. And so that's why we cannot use it, because remember, diagrams are not to scale. I think maybe you guys were getting like lulled into that sense of complacency when all the previous circle questions we had done, like the diagrams were pretty important. But in this case, diagrams are not to scale. Manit says EAB is similar to CAB. Okay, so that is a true statement, Manit, but that doesn't necessarily mean that this is an equilateral triangle, because remember, they have different ratios. So it'll actually end up being that these sides are different lengths because of the fact that these are like similar and not congruent. So yeah, I would actually argue that's a reason why it's not an equilateral triangle. Yes. Never trust a diagram. Always remember, never trust a diagram. Good. Okay, so yeah, I hope that's clear why this is not true. Coven, let me take a look at your explanation. I must have missed it. Yes, Kevin, that is correct. Just make sure you understand like where those numbers are coming from and why like this is enough, and why we don't have to really do much else. But otherwise, yeah, I would say that's all the correct calculations. Okay, awesome. Cool, cool, cool. So we have a couple of different options we could take. I think this is like a good break from our wait. I feel like this is a good break from our circular questions. So we have like 15 minutes left. So let's go back, return to our circular questions now. So do you guys want to do like, let's see. Okay, we have like four different questions. So I'm just gonna pick actually. Wait, okay, so a hard question. We'll do a hard question. Awesome, awesome. Let's do a hard question then. Alrighty, let me pick a good one. Okay, I feel like I feel like this is more like working with square roots than an actually difficult question. Um, this is AMC 8, which you guys have probably done. Okay, the next couple questions are like AMC 8 style, but okay, I feel like we'll do this question because I remember I struggled with this question when I did it. Maybe you guys are like smarter than me though, and you'll get it. Okay, here we go. Awesome sauce. This is an AMC8 problem, so maybe you guys have done it before, but I do remember like this is not an easy problem for me when I did it, so I found it a little difficult. I can't remember. Gosh, I did the AMC8 like years ago, so I really couldn't tell you like how old I was. Maybe I was like, let's see, I'm 17 right now. I did the AMC8. Wait, this is okay. Yeah, I would have been 10 or 11. Yeah. Yes, yes, yes. But like I was never good at geometry, so I think that's why I struggle with it. Yeah, don't get intimidated by the diagram, because sometimes this diagram has like way more stuff than is like needed. So I would always say like read the question first before you take a look at the diagram. Oshruth asks, is the triangle isosceles? That is a question for you to figure out because it is not given to us in the diagram. It's not given to us in the problem. It looks isosceles in the diagram, but can you prove it? Can you show that it's true? Okay, I bet he put in an answer of 64 pi, super fast. I like how you spelled pi, I think that's my favorite way. Kevin put in a decimal answer, but that looks close to be 64 pi. Kevin, I would say. Vishen says 64 pi, Monique says 108 pi. Awesome, awesome. Cool, maybe we'll have someone explain this one. Vaibahi, would you like to unmute and share how you got 64 pi? Okay, no worries, no worries, no worries about the mic. Vishith, would you like to share?
So I got 64 pi, and the way I got it was it said AC is 10 and AD is 16, and it said that C is at the center. So I know that AB is 8 and BD is also 8. And then I found out that CB is 6 according to that.
Oh, good work. I like that.
And then I got pi 10 square minus pi 6 square, which is 100 pi minus 36 pi.
Awesome. Let me see. You were super fast and I just like could not keep up. And then yeah, so you get 100 pi minus 36 pi, which gets you to that answer of 64 pi. Amazing work, Vishith, and thank you so much for unmuting and sharing that. I think that was a very clear, well said explanation. Alrighty, let's take a look at the chat, see if everyone agrees with this. Ashit agrees. Cool. Vaivahi agrees. Great. Okay, awesome. And I like what Coven says about a squared plus b squared equals c squared. Okay, this is really good work. Yes, so this looks intimidating, but honestly, it's a pretty simple like Pythagorean theorem problem. So Vish did a really great job like targeting that and figuring that out. So to start off, like we know that AC, which is one of our lengths, is going to be 10. AD is 16. That's all given to us in the problem. I would say the hardest part of this problem is being able to say that like AD is actually bisected by CB. And the reason why that is like this is not given to us in the question. This is something like we have to prove on our own. Like, do we actually know this is bisected? And I would argue, yes, we do, because if you think back to our circle theorems from a couple of weeks back, we said that if there is any like, if there's ever like a if there's ever like a radius or diameter and you're kind of like intersecting a chord or a tangent, that if that intersection is a right angle, if it's perpendicular, then your chord or tangent will always be bisected. So in this case, because it's a right angle here, we know that this is bisected by this entire like radius thingy. So we could say if the entire length is 16, half of it is going to be 8. So once we use Pythagorean theorem, we're able to find that the shorter leg is 6. Okay, so we want to find the area between these two circles. So we have two concentric circles, which means same center. One of the smaller circle has radius 6, larger circle has radius 10. So to find the area between them, which is like this donut-shaped thingy, we just do some subtraction. 10 squared pi, which is 100 pi, minus this smaller circle, which has radius 6, 36 pi, is 64 pi. Okay, in retrospect, that actually wasn't a difficult problem. I don't know, maybe this is the one I actually struggled on. I definitely struggled on something that looked like this though. But yeah, okay, I'm really glad you guys were able to solve this. And once again, thank you, Vishnu, for unmuting and sharing. I see no questions in the chat that haven't already been answered. So let's go ahead and move on to I would say this is gonna be our final question. Yeah, let's see if I can actually pick a hard one. That is gonna be challenging. Ha ha ha. Okay. Oh, you guys want to do a fun one? Okay, let's do a fun one. Okay, this is definitely a fun one. I think it's probably an easy one too, because you guys will know how to do this. But that's okay. I think it's fun, because I like working with this shape a lot. Okay, cool. So here's our, again, really long paragraph problem. And here is our diagram. Okay, stellar. So I'll give you guys a couple seconds to think about this, and then we will solve our very last problem for this class, as sad as that is. Ashita's, how do you find the area of a hexagon? Okay, this is why hexagons are my favorite, because they have so many cool properties. Let me give you a hint. I am going to draw the center. Oh, that's a horrible color. You gotta pick something more fun. I'll pick this one color. Okay, here's the center of our hexagon, supposedly. And here is a triangle. That is your hint. I realize this question is missing a period. Let's add that in. Oh, that was kind of just like a dot. Okay, cool, that's fine. All right. Malvin says 6. Wait, I definitely disagree with 6. I don't know if that was an answer or like an answer to someone else's question. Okay. Neat says 54 squared 3 minus 18. Okay. Cool. Vaivehi says the same thing, but they add a pi to it. Awesome. Rashab is confused. All good. No worries at all. Oh, okay. Madhava's answer coming. Okay, cool. Because I was like, 6 is definitely like nowhere close. Okay, awesome. Okay, so I think Winnie and Viva here are in agreement. So let's do this last question together. So, like I said, love hexagons because they're super cool to work with. And I gave you guys this hint for finding the area. So let me expand on this hint. What we're going to do is we're going to take a hexagon and break it up into 6 equilateral triangles. And this is why hexagons are really cool. They have a lot of properties that can just be found based on equilateral triangles, and that's because they all have angles with 120 degrees. So anything that's like a multiple of 30, like 30, 60, 90, 120, like all that stuff, really fun to work with, okay? So hexagons, super cool properties. For today, we only need to know the area of the hexagon, because if we can find the area of the hexagon, we'll just take that, subtract these these circular bits, and then we'll find this shaded area in the middle that is like a little star wonky looking thing. Okay, so how to find the area of this hexagon? Basically, we need to find the area of 6 equilateral triangles and then multiply them together. So the area of an equilateral triangle is the square root of 3 times 4 multiplied by the side length squared. And because we have 6 of them, I'm going to multiply this entire thing by 6, okay, like at the end. All right, so if we go ahead and evaluate this, we'll get 36 divided by 4, which comes out to be 9. So 9 squared 3 times 6 is 54 squared 3. Okay, and then we look at these arc bits, and that's how we find that area. So I'll use this cool, like, pink color. I feel like that's a fun color. So we know this is 120 degrees, like this bit here, which means it's 1/3 of a circle. And we also know that we're told to have radius 3. Even if you weren't told that, it's like pretty easy to understand why, because you're told that their center is each of these bits. And if they fill up perfectly, they obviously have to have a radius of 3. So if I have this radius of 3, the area of my circle is going to be 3 squared times pi. But this is 1/3 of a circle, so I'm going to multiply by 1/3. But I have 6 of these put together, so then I'm going to multiply by 6 at the very end. And when I go ahead and simplify this, 3 squared times pi is 9 pi, divided by 3 is going to be 3 pi, multiplied by 6 is going to be 18 pi. And so the area of the shaded region is going to be the hexagon in blue minus the circular arcs in pink, coral, kind of, and that'll give us our final answer of 54 squared 3 minus 18 pi. Okay, and this is our final answer for our final problem of our final Introduction to Geometry class. Amazing. Wow, that was really, really crazy. I hope that was a fun problem. But yeah, let me see if they have any questions, any last questions to ask. Cool. Awesome. All right, so Vineet, thank you for giving that formula in the chat. That's definitely like, you're usually able to find that out from the equilateral triangles. But yeah, Astrid says, I got what we subtract, but not the area. So there's actually no way to simplify this, so this would actually be our final answer, just because like all the irrational parts are like not in common. Yeah, awesome, awesome. Vivahi, thank you for putting a very detailed, excellent solution in the chat. That is absolutely correct. Cool, yeah, I'm glad you guys learned the area of the hexagon. I think that was fun. And good work, Winnie. Even though you haven't gotten answers correct, that's totally okay. I love the participation. That's awesome. Okay, one question from Atharv on how we get square root of 3 over 4 times 6 squared. So that's going to be the area of this, this equilateral triangle, which has side length 6, and then we just use the equilateral triangle formula. So this is the area of an equilateral triangle, and because we have 6 of them, that's why we'll multiply by 6. So hopefully that's clear. Okay. Alrighty, so now that it is 8 o'clock, we'll go ahead and end. I hope you guys learned a lot, and I hope you guys had a lot of fun. I've definitely enjoyed teaching you guys all this semester, so it's been really, really cool. We will open up classes next semester, so like don't worry, this is not the last time you're going to see me. But yeah, so definitely keep an eye out for that, and yeah, I guess like thank you all for like joining, staying active. It's been very meaningful, and I hope to see you all next semester. Alrighty, bye everyone. See you all, and please keep in touch. Let me know how everything's going, and if you guys have any like suggestions or recommendations for classes that you want to see, feel free to reach out because I'll still be brainstorming that over the next month or so. But yeah, bye Amari. Thank you so much. Bye Atul. Bye Bashir. Thank you, and I'll see you soon. Bye, Kevin. Thank you. Oh, Ashrit says probability. I will definitely keep that in mind, Ashrit. Thank you. Bye, Rishav. Thank you so much. Bye, Ditya. Amika asked after number theory and geometry what classes will be there. I'm actually not sure yet. I have to figure out like what slate I want to do. But if you have any suggestions or any content that you want to go over, like feel free to like message me so that way we can maybe incorporate that. That'd be awesome. But yeah. Bye, Darv. Thank you so much. Oh, and because it's trick, yes, we can definitely do that. Cool. Bye. Ashraf has a quick question. Yeah, Ashraf, go ahead.
How I remember the equilateral triangle area formula. I don't remember there being like 6 squared. I thought it was just square root of 3 by 4 times 6.
So the area of an equilateral triangle is the square root of 3 over 4 s squared. If we didn't square it, then it would kind of just be like perimeter, right? We need that square to get that area dimension, because area is always like two lengths multiplied together. So that's where like that square kind of is from.
If we had a pyramid, would it be cubed? Or is that a completely different thing?
It's okay. So if you had a pyramid, if we had a 3D shape, you're multiplying three lengths together. It won't be like square root 3 over 4 s cubed. The formula will be a little more complex, but it's like something of that nature. Yeah.
Okay. Yeah.
Awesome.
So after this class, there's no more classes on Monday.
No more. Yeah, not until next semester. Next semester classes might be on a different day.
Okay. Bye. Thank you.
Yeah, bye, Usher. Thank you so much. Awesome. All right, if you guys have no more questions, Akshin, Rishav, or Sai Praneeth, I'll go ahead and end the meeting. Thank you guys so much. Bye, everyone.